This is tension in a string, but now we're going to have the object hanging over the edge of something. Usually it's the edge of a table. So what we'll do is we'll draw ourselves out a table. And you're going to have an object on that table. And usually you have a pulley, and the object goes over the pulley, and then some other object is what's pulling this one over the edge. No tricks here. If this mass is bigger than this mass and there's a friction on the surface, well then this isn't going to move. Well, you have to check. But so they could try to trick you, but I'm not going to do that. I'm going to make this thing 3.5 kilograms. I'm going to make this 9 kilograms, and the coefficient of friction that I'm going to give you, 0.12, is just not going to provide enough friction for this thing to not slide. So it is going to slide, and what we're going to do is we're going to find the tension. And since it's one rope, it doesn't really matter where I find this tension. The tensions are the same. As well as, I guess I'm going to have to find the acceleration of, and I'll just pick one of them. It doesn't matter which one I pick, so I'll say it's of the 9 kilogram object. So I'm going to find the acceleration of this one. When I find the acceleration of the system, though, it's the acceleration of either one. So that's just a way of saying find your total acceleration. Your applied force this time is actually going to be your force due to gravity. So you don't have to be given this. You can just be told this is 9 kilograms. Force due to gravity is pulling down, so that's going to have to be 90 newtons. That is where we're going to start. Make this question easy. Do yourself a favor. Your first step, turn this into a linear situation. Because this is a pulley, it's transferring the direction of force perfectly. We don't have to worry about any losses due to friction in the pulley. That's something you'll take over in university. What we do is we just go back and say, well, if this is 3.5 kilograms, great. It's going to have a frictional force pulling us backwards, so I'm going to insert that, frictional force. This is 9 kilograms, that's nice. It's got no frictional force because there's no friction here, but force of gravity is pulling it down. So that I'll just put down as 90 newtons. And there's my tension. Pretty easy setup. Now this harder problem turns into something really easy when you do it as a linear situation. And I'm going to find the acceleration. That's going to be my second step. So find the acceleration. It's not acceleration in the x direction this time. It's actually acceleration down for this one and to the right for that one. But the number is going to be the same, and that's all we're really going to be concerned with. So let's take my sum of my forces on this situation. So I'm not going to call it sum of Fx. I'm just going to say my sum of forces. It's going to be equal to 90. I'm going to add it to my force of friction, which is going to be in the negative direction, and that's going to be equal to mass times acceleration. Mass net times acceleration. So that's going to end up being 90 subtracted by my mu, Fn, and that's going to be equal to 9 plus 3.5, I'll just write that in, A. 90 subtract 0.12. Normal force, it's the normal force of the one that's on the surface, which is this one, so that's 3.5 times 10, so that's 35. And that's going to be equal to 12.5 times the acceleration. So 90 subtract 85.8. No, that's not right. 95 subtract 0.12 times 35 is 4.2. Equals 12.5a. So at 90 subtract 4.2 is 85.8. So that's going to be 85.8 equals 12.5a. So I'm going to come over here. So I don't know if you saw that. 90 subtract 4.2, which is 85.8, equals 12.5a. So my a is going to be 85.8 divided by 12.5, and that ends up equaling 6.86. So 6.86 meters per second squared. I'm not going to write down a direction. Okay, if they specifically ask you, what's the, well, I did. I said, what's the acceleration on the 9 kilogram object? So that, because it's down, you'd put a negative on here. Okay. If they're asking you for the acceleration of the 6, well, then it's to the right, so you'd put a positive on there. Because I asked for the 9, I'm going to put a negative. It's right there, but I'm not going to use that negative anywhere. I'm just going to use it to answer a question if this was a multiple choice or here. For my third step, I'd like to find my tension, which is what I asked for up here. So find tension. So to do that, find T. I'm going to use my linear situation. I'm going to remember that this is the only spot that actually affects the tension. So when I do my sum of my F's, I'm going to get tension added to negative force of friction equals ma. This time it's not m net, it's just mass of that times the acceleration, which I figured out here, but not with a negative. So let's see, tension, subtract mu Fn equals ma. So my tension is going to end up equaling mu Fn plus ma. So almost done here. Mu value, 0.12. Normal force, 3.5 times 10 is 35. Plus the mass, 3.5. And the acceleration that I got was 6.86. So adding that all up gets me a tension. So let's see here. 0.12 times 35, that's 4.2. Add it to 3.5 times 6.86, that's 24.01. So your tension ends up equaling 28.21 newtons. Ran out of space just in time. So there you go. Tension is 28.2. So I can put that up here, 28.2 newtons, which is here. So that could be 28.2. This is 28.2. It's 28.2 all over this tension because it's just one string. There you go. Okay.